Hello students. Now let us take up the discussion of the colligative properties one by one. See students, colligative stands for co plus ligar. Say in a Latin language, co stands for say together, ligar stands for to attach. Therefore, these two put together, it will become colligative. Okay. We can call colligative properties in this manner. The collective physical properties are known as colligative properties. The collective physical properties are colligative properties. Okay. Now, let us deal with one of the colligative property first. First one is a relative lowering in vapor pressure. Okay, students. Okay. Here we use the Raoult's law. See, students. Vapor pressure of the solution, that is P1, from the Raoult's law is equal to mole fraction of the component present in the solution into vapor pressure of the solvent in its pure state. Okay, students? Okay, this is from the Raoult's law. This is the mole fraction of solute. This is the vapor pressure of the solution. This is the vapor pressure of the pure solvent. Okay. Okay. As we are dealing with lowering in vapor pressure, it means that vapor pressure of the solvent in the pure state and vapor pressure of the solution, if they are compared, which one is more? This one is more. Yes, students. Therefore, P01 minus P1 is known as lowering in vapor pressure. That means how much is decreased? Decrease in vapor pressure. This is also called as decrease in vapor pressure. This can be represented as delta P1, or we can call it as delta P1. Okay. Now students, we notice that P0 minus P1 is equal to, see students, what is this P1? P1 is x1 into P01. That means this can be written as P0, this is P01, P01 minus P1 is this, mole fraction of 1 into P01. So here what is common is P01 is common. That means here it will be 1 minus x1. Clear, students? That means this is what? This is delta P1. Clear, students? Now, we know that x1 plus x2 is 1. Therefore, 1 minus x1 will be x2. Clear? Now, from this what we can get is, see here, delta P1 is equal to, what is this? 1 minus x1, 1 minus x1 is x2. x2. And this P01 remain as it is, P01. See students, this is lowering in vapor pressure. Clear? Now, this lowering in vapor pressure, if it is divided by the vapor pressure of the pure solvent, then this will be regarded as relative lowering in vapor pressure. Okay. This relative lowering in vapor pressure is equal to, what is this? Mole fraction of the non-volatile solute added into the solution. Clear, students? Now, see students, we notice that mole fraction of 2 will be equal to number of mole of 2, second component, that is solute, divided by total number of moles, that is N1 plus N2. Here 2 stands for solute and 1 stands for solvent. Okay. Now, for dilute solutions, N2, that is number of mole of solute, is less than, very much less than number of mole of solvent. Therefore, N2 can be neglected. Clear, students? That is, N2 in the denominator can be neglected. Well, this is not the always case. Sometimes you need to consider N2 also for calculating. In some problems, we need to use even N2 also. But now, let us simplify this. Assuming that N2 is very much less than N1, then what we can prove? X2 will be equal to N2 by N1. And this N2 is number of mole. Number of mole is, that is, weight divided by, see, we know that number of mole is equal to weight divided by molecular weight. Clear, students? That means N2 is W2 divided by molecular weight of 2 divided by W1 whole divided by molecular weight of 1. That means X2 will be equal to W2 divided by M2 into, what is this? M1 divided by W1. Therefore, this relative lowering in vapor pressure is equal to W2 M1 divided by M2 W1. Okay. See, students, this relative lowering in vapor pressure help us to calculate what are these, what all we can calculate. See, students, we can calculate molecular weight of solute added by knowing the weight of the solute, and we can calculate molecular weight of the solvent also. But most of the time, what we notice is this problem is used for the calculation. Not only this problem, this concept of relative lowering in vapor pressure is used for the determination of molecular weight of the added non-volatile solute. The application of relative lowering in vapor pressure is one of the most important application of relative lowering of vapor pressure is to find out the molecular weight of the added non-volatile solute. Remember, students, this is lowering in vapor pressure and this is relative lowering in vapor pressure. And see here, whether it is lowering in vapor pressure or relative lowering in vapor pressure, both depend on mole fractions. Mole fractions ultimately lead to number of particles only. Clear, students? Number of particles. That means whether it is lowering in vapor pressure or relative lowering in vapor pressure, these values depends only on the number of particles. Hence, both are colligative properties. Clear, students? Whether it is lowering in vapor pressure or relative lowering in vapor pressure, both depend on number of particles only. Therefore, both are colligative properties. Clear?